Yeah, I mean, thank you so much, everyone, for organizing this event. It's wonderful to see all the familiar faces and, meet up. And we all work at different companies, but it's just really nice to see everyone. So yeah, this is an exciting topic. We're going to talk a little bit about hardware and how that's going to go. And I think I'll just start off by letting you guys introduce yourself and maybe give a bit of an introduction, and then we can switch to kind of a more conversation style after.
Sounds good. I'll start since you're looking at me. My name is Vipin Jain. I am a senior fellow at AMD, mostly working on building the P4-based NICs and inserting those NICs into the switches, which was referred to as Smart Switch earlier. So that's the experience at Pensando. I was one of the co-founders at Pensando.
Actually wrote up something. Okay, so my name is Anjali, principal engineer at Intel, and I wrote up a little bit of an introduction because these days wherever Intel folks go, the first question is asked, are you still at Intel? So I'm still at Intel. And the reason is Intel and I are still aligned on our value system. So I guess Intel DNA and my DNA is still matching. And, there's some 3 A's in there that match. And, I'll not go into those details right now, but yes, still at Intel. How's Intel doing? Intel is bleeding blue, hopefully for a good cause. Don't know yet. Business is not great. Technology is still very good. And Martin said, we need to protect innovation as a nation. So I will just take that as Intel is on the right path. Hardware offload at Intel. Well, the one thing that we do good is hardware. So hardware offload is still what we will continue to do at Intel. We are making things more and more programmable, scalable, configurable, and stable, hoping that the right investment also means good business. So, and the last thing, Martin Casado said, network engineering will always be in fashion. So I am very happy about that.
All right. Yeah. Thanks for the introduction. So yeah, let me maybe start off with just like a very controversial question. Like we're writing our. Oh, go ahead. Oh yeah. Sorry. I'm Konstantin. Konstantin Weitz. That's good enough. You should know me. From the movie. So I was working on P4, before Stefan joined, and was working on the symbolic execution and built a lot of those things. Also worked quite a bit on the NIC to make that work, make it more programmable, give us more flexibility in that space as well. So that's kind of my background. These days I'm focusing a lot on ML networking. So you might get questions in that direction as well. Okay. So yeah, let's maybe start with one thing is, P4 has been an incredible programming language, right? To like express these ideas of how my switch should work. But what I see is at the end of the day, we still end up with multiple P4 programs. We have like one that specifies the semantics, but then our hardware vendors always kind of have trickiness in their hardware. And so we need to write another lower level P4 program. Are there like ideas to kind of, maybe have better compilers or standardize more of your hardware to make it a little bit easier to have like something that really works across vendors perfectly?
Okay, I'll go first. So I think we have been, since last 5 years, I've been working on hardware that does P4. And I can say that, the rate at which we are innovating is absolutely amazing. So it's a balance. If you want speed, portability is going to be very, very slow. because you just want to go and innovate on things and all that. It's like kind of gold rush, how AI and other things happen, where you see gold, you just rush towards it as fast as possible. Then you think about homogenizing it. In a way, it's not a bad thing, because let's first figure out what are the prime use cases. I think we have talked about some use cases that have been like really spot on for P4. After having worked on it for these years, I can say that we have actually identified some use cases. It makes sense to standardize things a little bit at that point, and I think this is the right time to do that. But at the same time, community is the way we want to do it. And so let's bring all our use cases together, talk about it exactly what are the constructs that are needed in order to achieve those use cases, and do we have those constructs or not? And if not, go propose that as an architecture change to whatever is there, as a language change to the specification, or potentially a radically different concept.
Yeah, that all makes sense. I mean, I agree, right? To some extent, we want to both innovate and standardize, right? And it's always going to be some sort of trade-off that we have to do.
Yeah, I can completely agree with what Vipin said. A few things that we could do, and I think we have talked about it a little bit. PNA would be a good thing to standardize, have some specifications on it that would help. The hardware architectures will independently evolve. That's more, the innovation that comes from the different companies and different ways of optimizing power, performance, all that stuff, right? And that's dictated more by, again, business and economy and everything, which market we are trying to pitch the product in and everything. But I think P4 is very organically evolving, and it's headed in the right direction. We just have to make sure we do a little bit of course correction here and there by standardizing things.
I would like to add, there are 2 more vendors at least. It's supposed to be here. Why not? Why not? Because I think it's a very crucial part to standardizing things.
Yeah.
Yeah, absolutely. And I mean, one problem is also, right, the fact is there are multiple ways to build a hardware that makes sense, right? And so you need to find an abstraction that just like works across everything. Taking maybe the topic of, things are complicated. So I used to work a lot on the switch. These days I work more on the NIC, and we have like the switch, like the stage where you like transform the packet is like a small thing wedged into like queue handling and all that other stuff, right? Can we get like P4 for all the other stuff, or programmability for the other stuff? Can we standardize on like vendor agnostic ways to like deal with queues or congestion control or connection management, things like that?
That's so near dear to me. I mean, I want that. In fact, I'm trying to get that in the community. I'm trying to propose things that, that goes in that direction, where I think I made a statement that actually network doesn't start on the Ethernet port. Network starts right on the host when the handoff happens to the IO device saying like, please send this over to some place. And so interfacing with the memory, interfacing with the queues, handling messages is something as a product I can say our product supports. We know what kind of challenges are there. We are trying to make it mainstream by proposing things in the PNA architecture. And to Anjali's point, let's all come together and standardize that. So I think it makes a lot of sense to what you're saying. The use cases are more complicated. The good part about P4 on the NIC is that it is not as much scale challenge and restricted on how much of instructions you can afford to have that strict pipeline that is defined in standard, let's say PSA. So you can afford to bend the architecture a little bit, go to run to completion models, try and introduce concepts that don't exist today, loops, timers, asynchronous events, queues, all that stuff is music to my ears.
All right. I mean, we still have to pay attention to throughput and latency, though, too.
No,
I know what you mean.
I'm saying that from actually build a product. So I can tell you there are ways to get all that and yet achieve these things. So I'm not saying this as a theoretical exercise here. Clearly, having something in hand and working gives us more confidence. Gives us as a community, it gives us more confidence to build it than us discussing the same thing 4 years ago when we just had a device and we did not validate these things.
Yeah, I can't agree more on that one. So yeah, there are a lot of these abstract concepts like I mean, it has been in the industry or, in the compute and networking industry. These terms are, like existing forever. I mean, that's what it feels like to me, right? The queues and the memory and the, buffers and events and, loops and stuff like that. So the language has to evolve a little bit. And I think we talked about that a little, last few days. But at the same time, the other constructs, which are more, I guess, externs that come from an architecture like PNA, we have to talk about that and standardize those.
Yeah, so the last topic, maybe or maybe another one after, but one topic that I can't miss these days is like, can we do stuff around ML, right? And so, I mean, one thing that when I started diving into this space that was actually fascinating to me is that NVIDIA is doing a lot more in their switches these days, right? Like they're, for example, doing like reductions of weights and so on. And I'm like, whoa, that's like what we always dreamed about with P4, right? Like enable these use cases that come up as they come up, right? Where do you see that heading, both in the NIC and in the switch? Is there something we can do with this programmability to like solve these use cases in this very rapidly evolving space?
To me, ML is just recursion and being able to come out of it, when you need to. That's pretty much how I look at ML. And I think all our architecture, they have loops. And as long as, the conditions are done right, we'll not heat up the part and not go into endless loops and burn up the part. But yeah, I think it's really good and we should be looking more into it. Yeah.
So I think P4 as a community has been looking for a killer app. And we always like get into something and then we try to steer packets for key value, restore. And I'm not saying they are great things, but yes, I mean, is that the killer app for P4? I think, if you talk about AI and ML and clustering GPUs as a general, why is P4 better? Or for that matter, why is programmable thing better there? So I would give like 4 or 5 reasons why, and they are quite apparent. First one is that AI cares about latency and performance. To the nanosecond levels, I would say. If you are increasing any bit of latency, they don't like it. So that means you have to do something in hardware. You can't do it in semi-hardware or software is a long shot. You need flexibility as well. I mean, there are so many congestion management proposals out there, so many ways of doing transports, and it's evolving. We are at the beginning of this, infrastructure build out for AI, which means people are going to come up with ideas as to how this could really take off in a big way and come up with newer things, which means whenever you're at the infancy, you need flexibility. So you need speed, you need flexibility. Speed, including latency and speed into the same bucket, of course, but you need super high speeds, like, 400 gig, 800 gig minimum coming out of one GPU, and then, multiply that with whatever your GPU cluster size is in multi-plane networks. So you need speeds, you need latency, you need flexibility because of all the advent of newer protocols and or newer congestion management methods and or potentially things that we haven't talked about yet, because like I said, this is evolving. The last thing is when we often talk about the implementing the congestion protocols and or other things, we always think of like this data plane and this control plane. I think someone made a statement earlier, I forgot the name, but anyway, which was that the old control plane is my new data plane in AI world, which means whatever used to happen in your general data path needs to happen in P4 now for hardware speeds, is what I mean. P4 as in, you can validate that in software, of course. The reaction times for some of these jobs that happen at the cluster level is not tolerating of the things that could happen in anything but hardware. I mean, we are talking about, GPUs are used to basically on the same motherboard. You took them apart and put them in different computers, but their expectation is still the same as if they're on the same motherboard, which means the things that would happen for GPUs to interact with each other or for any memory transaction to happen, you have to be able to do it in a way where you cannot even afford to find out if a path is broken in a network in software. You cannot afford to find out if I have an alternative path in software. So am I saying that routing protocols need to exist in P4? Routing protocols, I'm not saying data path for forwarding. That's the thing of past. But in a way, yes. I mean, I'm not saying you have to run the entire software stack there, but you have to be able to take a gist of how to work around network issues, network problems, and all that in the hardware runtime in the matter of tens of microseconds or maybe less than millisecond. Milliseconds already too late. It's like, the job is going to time out at the higher layers. But anyway, that's my talk.
Can I add some more?
Yeah.
So, I mean, what Naveen said is, to the point, just two more things that I'll add. One is, yes, latency is very important. Even more important is tail latency or jitter in these AI networks. And I think I'm quoting Van Jacobson here, because that's how you get the scalability. And then the about time, right? So these devices need a lot of time-based functions like precision time, protocols, PTM, and things like that, because otherwise we have no congestion control, no crypto, none of those work if we do not have precise time, right? So all these modern devices, I mean, unless we can synchronize every device at the same clock time, and that is, I'm talking in nanoseconds, we are not having a communication here, right? Because that's the scale of synchronization that's required.
Yeah, I mean, I can definitely second that from my daily experience. Like when you run 10,000s of GPUs, right? Like if one of them is slow to participate in the all reduce, they're all slow. So tail latency is definitely very important. Yeah. All right. Are there questions in the audience?
I think I have been calling Vipin Naveen. I'm sorry about that.
I'll ask loud. Actually, I have a question for Konstantin first.
Sure.
From your perspective at Google,
Yes.
I have it.
Konstantin, so from your perspective of Google and your recent experience and looking to what do you want out of the next generation of NICs that you haven't seen?
Great question. I mean, one thing I would really like is make it easier to have the GPU communicate directly with the NIC, and zero copy for basically everything. Right now, when packets arrive, we still have to then have GPU cores reassemble them because they might arrive out of order. Have more smarts in the NIC to actually handle that. Also make it programmable so we can access it. So even if that feature exists, we want some sort of way to access it that goes across platforms. And then the other thing is, in the network itself, it would be really cool if we could accelerate some of those ML applications. Right, it's kind of crazy, when these ML workloads reduce all their weights, right? Everyone computed their weights. Now they need to average it out. They send it to each other and they all average it and send it around in circles. Why can't the network just like do it and then send it, the result to everyone, right? So those seem like really cool things that I would love to see in the future. Along with more speed, more lower latency. That's always good.
First, I have one funny comment about latency, how latency is important. I have a 12-year-old son, he plays games. And I don't know if he heard me or not, but every time he's lagging, he says, I have a latency. That's what he says. Now, about other things we talk about, you talk about before about the protocols. And we know that the traffic management is not programmable right now. And that's one of the big problems. And with one of our students, and now I'll have another one actually, we spent quite a bit of time try to see how can we create a programmable traffic manager. And that's kind of a hard problem. And then with one of our students, we took the PIFO model and we created some kind of a dynamic version of it. And now we have one, his third journal paper didn't come out yet, but that one tried to analyze what kind of operations will be needed to be supported, and some of them are actually complicated for the data plane at the moment, in order for the language to be able to implement this kind of, at least, I don't know, we analyzed 20, I don't know, many different protocols basically. Say, what's the key operations that right now are missing from the language? And so at one point, this is a difficult problem. We're going to have to find a way to have this implementation language, but also in an efficient way that data plane can handle. Like if it's a multiplication, for example, or division, how can we do this in a data plane? So that's what makes, I think, the problem hard. And we have another kind of idea with another person, with another student, but it's kind of in infancy now, but yeah.
Okay, so I believe you asked 2 or 3 questions in there. And yeah. Anyway, the first one was like, how to handle the programmability of the data, data buffering and congestion aspect of things as well, right? And I believe you're talking about from the switch point of view more than from the NIC point of view. Yeah, that's what I figured. Okay, so I'm not a switch vendor, so with that caveat, I can say that there may be a different place to solve the problem instead of trying to solve it at the switch. For example, if there is buffering or congestion happening on the switch, maybe that's not always the best place to solve it, because if you can measure the reaction times quicker at the endpoints, you may be able to avoid the switch as long as you can get the network reaction to be communicated back fast enough, which is what I was telling earlier, that you need to be very much path aware on those things. So if this is not to say we don't have to solve for potentially the programmability at that. And I can go into, from my experience of switch architectures, as to why this is difficult. Because if there is one thing that is like dealing with in the switch, and ignoring my first comment, which is like maybe there's a better or different place to solve that problem, if at all there is things that are happening there. But the part about switching architecture typically is that there is this packet coming in, ingress, you parse a bunch of stuff, you do table lookups and all that, and then you let it go through this fabric. The fabric component is actually very complicated, and its job is packets in, packets out to different ports, input-output queuing type of architecture. The level of programming that is provided today is to be able to deal with buffers and queues and potentially how much you want to carve out for what kind of classes, and you can feed in all this input from the lookup engine to impact that. But if you really want that behavior to change the way the queuing itself is happening, not from the packet parsing, but using some other mechanisms, it's going to be tricky on real switches, I can tell you, because it's growing to become like tens of terabytes and even higher amount of switching happening there. You don't want to put a programmable element right there and jeopardize the overall capacity of the switch. Now, you could argue that that's why I'm saying maybe because the speeds are not that big of a factor on a NIC, it is possible to do some of these things where you make those decisions on end-to-end congestion related things on the NIC devices instead, and keep the switches simple. When I say switches simple, in the sense fabric needs to be stable. It's handling like hundreds of endpoints. Imagine one switch going down, taking down 20 GPUs versus, and this is again, I'm talking in context of AI, right? Versus one NIC going down, taking down one GPU. So complexity needs to move to the edge in that sense. But, you know,
Yeah, I was getting reminded of my control theory professor talking about control theory 101 class, like, you know, feedback and, you know, end-to-end stuff. So yeah, I mean, traffic management is that same exact problem, but, you know, which is the system that has to be identified, right? And I mean, the mistake made is like just the middle boxes is where you're doing. So you don't really want to manage as much as proactively plan for it, right? So you don't want to react to congestion. You want to do it in a way that you have enough feedback in the system so that you don't get in that situation, right? So I think end-to-end, the NIC and all the smart NICs have a lot of these things built in it now, where you can get all the feedback that you need, and you can design in-band telemetry and things like that that will help you in making sure, you know, you're scaling to a much larger network without having to deal with congestion and getting optimal utilization of the network. Yeah.
Right? Are we done? Okay, cool. Oh, okay. We have time for more questions.
Sorry, two more questions yet.
It's okay. Go ahead.
Do you think is there any sense to make some innovation towards the lossless networking here? Is this possible, or the speeds which are required for AI? Yeah. It is first question. The second question is related to the defining, for example, the DMA that way, for example, that is because you are talking about the passing data directly to the, for example, accelerators like the GPU, which are also the hardware, yes, which requires the special data structure is here to work efficiently. Yes, here today the transforming of the data when you receive using from the RDMA is made on the CPU and next is going to GPU. Yes, here. And do you think is it possible to, for example, using the P4 to defining of the some data transformation? Yes, here and in the NIC to achieve the better performance and to pushing data instead of to the host memory that to accelerator, which provides some kind of the acceleration is here.
I'll take the first part. Sorry, go ahead.
Oh, yeah. How about I answer real quick and then I'll let you. So for the first question, I think you're asking, should we use lossless fabrics? I mean, in general, I love the idea. The problem is, I think at a certain scale, it's really, really hard to keep your fabric lossless with all the possibilities happening, right? And so you probably need some sort of backup anyway. And then you need to make sure that when that happens, the tail is so important, right? That you don't completely destroy your tail. So I'm not a congestion control expert, but I do think there are quite a few trade-offs that you want to carefully consider. Obviously, there's lots of advantages too. And then the second question, in the NIC, can we do some of more computation? Is I think what I'm hearing. And yeah, I mean, we spend a lot of streaming multiprocessors on the GPU. To not do number crunching, not do matrix notifications, but do networking, right? Is that a good use of those floating point units? Probably not, right? And so, yeah, I think if we can offload more of that stuff to the NIC, that sounds great, right? Can we do reductions in the NIC? Can we do some of the protocol handling and so on in the NIC that we currently do today on the GPU? That sounds like great ideas, and I would love to see that. And now you sorry for
you said what I had to say. Yeah, I mean, I don't think there's an option to have lossless network. That shouldn't be an option on the table, because we live in a real world. And you know, so yes, the networks are getting really, 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 really good. But assuming you will not have one packet drop, I think that's fiction.
I think, the congestion propagation is real. People who have built bigger networks can assert to that. When I say congestion propagation, as in the PFC or the so-called lossless network, that's what you do. Because you can't transfer, you're going to pause the other guy. And the pause propagation can be, it happens at a link level. It has no idea about which flow is contributing to it. Basically, it's kind of like saying one guy is shouting, you're shutting down everyone in the room. And that works okay as long as the room is small, because you know exactly who that person is. You can say, well, okay, you can manage that on a smaller scale quite okay. But on a bigger scale of things, agreeing to what Konstantin was saying, it becomes almost like counterproductive beyond certain things. Now, if you are not a training guy who doesn't need to build a GPU cluster with thousands of GPUs, absolutely lossless networks are the way to go. I mean, why take on the complexity if you don't have to? So that's my take. Having said that, if you can create one way from the operations point of view, and now I'm flipping back to the practicality of it. If you have two ways of building networks and two ways of managing networks and two ways of verifying networks and two ways of creating two networks, its costs higher, operations are different. There are always two ways of doing things. What if you can do one way of doing both? Of course, you can choose to have a dedicated network, but at least there's exact same way to manage this network versus the other network. It's Ethernet switches like it used to be. It's IP networking like it is known to everyone. Why not go that route? So that's an argument on why lossy may be better even for not so highly scalable networks. So lossless should work, but to me, I think if we can give that runway in production deployments for lossy networks to work equally good or better, I think they could do better also, because you can avail a lot more tools with lossy networks that are not available in lossless type of things. But I mean, this is to be seen. Maybe we'll meet again next year and I will say, look, this works, or you were right. It's a thing. As a person who's building products, I don't want to take something into assumption until it actually proves out in the deployments in a big way. I mean, not just like small deployments or POCs kind of things. So on concept, you can prove it.
Yeah, I mean, our view is we have done both, and I think we have decided that it is lossy. That's the best utilization. Yeah, lossless doesn't scale.
The last one, the second question was like, can P4 be used to interface with GPUs and bypass CPU? That was roughly the question, right? I think I've talked about message passing proposal in PNA, and that exactly addresses like how can we start to have P4 be used to directly deal with memory. The moment you expose that, the moment you say that P4 can understand memory constructs and start to take, for example, whatever is residing, and once you say that construct exists for memory, it doesn't really matter whether memory exists in the CPU or GPU, honestly, because it's the hardware architecture on whether you have a dedicated linked GPU or you have the standard PCI, all that, and we won't go into that part of the product, but architecturally exposing a message level API as a message level architecture wherein P4 has constructs to actually speak to an entity which is memory, both in and out, and be able to manipulate those things natively, fetch those things, process them, either give it back to memory or towards the network, then yes, it's possible. And that's the proposal we are having. I encourage you to come join PNA discussions for that.
I don't have a question. As I think Mohammed and I would like to thank our panelists and invite everybody to go out to the reception food that's waiting out there.
Okay.
Thank you, everybody, for coming. Go out and make some technical and social friends while you're here, please.
Sorry, before we leave, can we also thank Andy and Shabazz?
Yes,
from RPC Trace?
thanks for organizing.